Alright, the General Electric Series 7, Section 12, Instruction, Troubleshooting, Introduction, Troubleshooting, Procedure, Safety Notice, Troubleshooting Guide, Preliminary Check Engine Shutdown, Preliminary Check Engine Running, Preliminary Check Cold Weather, Engine Run Check, Loading Unit or Self-Load Check, Horsepower Trouble, the Turbocharger Trouble, Modulating Control, Governor Trouble, Check Constant Horsepower Excitation, Control Excitation System Trouble, CMR, wheel slip system trouble. Introduction. This section presents troubleshooting procedures as an aid. This section prevents troubleshooting procedure for the aid, correcting locomotive the problems to keep the locomotives online. With the list of some of the troubles which may occur, along with the most probable cause of the corrections, will be restored in normal working order. The information contained with the guide deals with those problems that will be corrected on the road at the terminal with a minimum of the time of the repair equipment. Certain problems are related to visual, audible, and warning indications perceived by the operator. Some of the indications are common operating failures, normal to operation of the road locomotive, yet easily overlooked. Those corrections procedures that should be performed with a qualified personnel having the working knowledge of the overall locomotive system, familiarity with the necessary test equipment required to perform these tests, and adjustment procedure also be necessary. Figure 12.1 shows turbo details, compressor end, air charge discharge elbow, turbocharger water discharge, turbo speed probe, steel air piping in from locomotive air supply, lube oil pipe header and suction pump, turbo mounting bolts, left bank intercooler, lube oil and gravity discharge pipe suction, ejector pump, lube oil supply pump with orifice, lube oil suction discharge pump, crankcase breather pipe, right bank intercooler, lube oil and suction discharge pipe. These instructions are intended for the general guidance assigned with the personnel suggested corrections or stay with the briefly and able experience maintain the rapidly scan and list of the pinpoint necessary correction of the specific trouble. They are not intended to prevent exhaustive treatment of the safety precautions preclude for an individual experience and inexperience with regard to the installation, removal, of operation, maintenance, of the repair of the equipment. In all instances, local safety rules should be the troubleshooting of the following of the procedures are not all conclusive, but should not be used as a substitute for the normal road troubleshooting procedures. These procedures are general guide that you use in addition to the normal road troubleshooting procedures, and as further aid to the maintainer. There should also be noted that the overall visual inspection check procedure is not included, but is covered in Section 2 inspection check. Alright, preliminary check engine shutdown. When the unit is sitting with the incoming track ready with into the shop, check the following. All available engineers report for the trouble check line with the railroad, line of the road with the reports for the road, reported trouble check the past work reports on use of repeats. Then go to the unit. If the engine shut down, the ravel to check with the announcing interpan with the two holding relays, engine temperature holding relay, and the ground shutdown holding relay. For lit indicator lights, check all the safety shutdown devices. Close the battery switch if it is open. If the indicator lights are lit, and safely shut down the found tripping devices to release from the correct. If no lights are lit, but none of the devices are found tripped, make thorough crankcase inspection on all the doors, looking for the dripping water, broke cylinders, skirts, scored liners, traces, or fine metallic particles, internal surfaces, and ledges of the crankcase, signs of any heat of any of the main or rod bearing caps. If any of the conditions are found, not only of the appropriate repairs of the items may be necessary, it also may require checking items such as the following: lube oil pump bearing housing for signs of heat, oil for crankcase for water and or viscosity oil out of limits, water level inside of a glass for the water tank, fuel pressure for the starting fuel pump. B. Removal of the cylinder valve with the cover to the inspect of the heat cylinder with the broken stuck valve with the broken rock lever of the push rod, loosen the missing of the tap nut for the loosened valve, keep it loose in the lock nuts, unusual conditions that may be evident. Seeing if nothing is found to this point, open the cylinder relief valve, manually bar the engine over the two complete revolutions, barring over, then looking for the water coming out of the relief valve, listening for the unusual noise, feel for any binding of the equipment. If nothing is observed that you upon up the point, close the cylinder relief valves, carefully try to crank the engine. Do not try to help the engine start by moving the lay shaft manually. No, if the engine does not fire within 60 seconds, the fuel pump racks do not come out of the 11 to 13 millimeter wheel. While cranking it, probably not going to start. To avoid the running of the battery down, do not continue with the cranking of the engine if permitted with the railroad rules. Pull the racks on the two only injection pumps out to the fuel rack while cranking. If the engine still does not start, leave it dead and proceed to investigate the possible cause. 5. Table 12.1. List the most common cause of the engine cranking problem, the engine shutdown problem of the table 12. The 2. The present the more detailed list of the component malfunction, electrical malfunction, locomotive system malfunction, including some of the one-time only occurrences. Should be noted that in some cases, the table 12.2, more than one shutdown device is shown with it being activated for the particular cause. Although 2 devices may activate, one of which require the engine shutdown. Also should be noted that the possible cause common table 12.1 lists the causes of descending in order probability. Thus, first cause listed with the most probable cause of the problem. Last cause listed as the least probable cause. Preliminary check engine running. If the locomotive arrived at the engine running at idle, check the following: operator's cap, engine lube oil pressure showing it to be at 20 psi minimum. Lube fuel oil pressure holding should be at its 47 minimum, 40 psi minimum. Alright, engine won't stop. Fuel pump won't run. The possible cause: the ground safety ground system dead header. GSDHR hold the ground safety delay hold relay is tripped. Reset after an analysis of fault. COP is tripped for analysis of the crank overpressure tripped over the engine shutdown device. Shutdown and fuel pump won't run. Shutdown the signal has been sent to the engine. Check all the other devices and contact emergency fuel shut off engine stop push buttons. Engine won't crank. Contactors don't operate. Fuel pump is not operating. Reset after the analysis of the fault. Barring over switch or BOS is open. Replace the cover of the barring over the driver and connect the cable. Engine won't crank. Contactors operate. Start circuit is malfunctioning. Check the brush of the communicator auxiliary generator exciter. Check the cables. The starting circuit. Also check for a 74 volt battery voltage. Engine won't start. Governor gap is greater than 1 inch. Stop signal is being sent to the governor. Move the throttle from shutdown to the idle position to clear the stop signal with the governor speed solenoid. One or more engine shutdown devices are tripped. Determine which device is tripped and the cause. See the engine shutdown. Engine won't start. Governor gap approximately 3/4 inch. Rack setting is less than 20 millimeters. Overspeed says system malfunction. Reset trip. Check the overspeed governor output pressure during the cranking. When the pressure should not be less than 95 psi. If the pressure is less than 95 psi, replace overspeed link at the end governor regulating valve. Engine won't start. The governor gap is approximately 3/4 inch. Rack setting is less than 10 millimeters. Misadjustment. Overspeed governor. Adjust the overspeed governor. Engine won't start. Governor gap is approximately 3/4 inch. Rack setting is 11 to 13 millimeters. Fuel supply problem with the fuel line of very low fuel pressure. Check the fuel supply fuel line if needed and add fuel to determine the correct cause of the low fuel pressure. Timing is incorrect. Reset timing. Crank speed is too slow. Check battery condition. Alright, your engine shutdown device is low oil pressure trip. This is automatically reset. The ground safety deadhead relay also trip, but reset after analysis, and also be tripped. Reset after analysis fault. Oil level, add oil. Dirty oil filters, replace filters. Oil filter tank drain back, close valve. Dirty lube oil cooler, oil side, replace cooler tube bundle. Dirt crankcase strainer, loose cover, replace strainer and secure cover. Faulty lube oil relief valve, replace valve. Dirty fuel filter strainer, replace filter and strainer. Fill slipping bond pump drive, replace bond pump drive. Hot oil because of low viscosity. Determine the correct cause of low viscosity, such as dirty oil filters, dirty lube oil coolers, dirty crankcase oil strainers, failed oil pump, replace oil pump, examine the engine bearing caps housing for the signs of excessive heat. Investigation correct causes. Excessive worn air engine bearings. During the crankshaft inspection, look for the evidence of the bearing metal on all crankcase ledges and carefully inspect for the bearing caps and signs of distress. Worn governor drive gearbox shaft bearings. Replace bearings. Worn dipstick. Replace the proper dipstick. Recheck oil level. During the cold weather, oil depending on dead end pipe of the governor's lube oil pressure device becomes very thick. Modify the dead end piping bypass. See GEMS Volume 5, Issue 2, September 30th, 1977. Defective diaphragm in governor. Replace diaphragm. Alright, your low water pressure, or LWP trip. This is automatic reset. Low water level. Add water to the also inspect the and locomotive cooling system leak. Remember the radiators of general electric locomotives are dry. Unless the water temperature is high enough to send the water to the radiators while the engine running, inspect with the crankcase for the cylinder water leaks. Check for water in the oil. Boiling LWP is tripped. The boiling water air pump at the pump inlet. Check the low water level of the malfunction thermostat. LWP tripped. Cooling system not pressurized. Examine the fill cap with a good gasket, with a fill pipe with the proper application filler cap. Also check for the cracked water tank site glass. Low water pressure switch trip. Dirty lube oil cooler water side. Replace the cooler tube and bundle. Lube oil cooler water inlet screen plug. Remove the debris and clean screen. Dirty fuel filter strainer. Replace filter and strainer. Failed slipping bonded pipe drive. Replace bonded pump drive. Defective diaphragm in the governor pressure switch. Check the water leakage of the low water pressure switch on the governor. Replace the diaphragm. Crankcase overpressure tripped. Oil level too high. Pull the dipstick and check the oil level beginning with the too high. Perform the test to check the presence of the water in the crankcase. Excessive level in the crankcase may be caused the cylinder the ceiling leaking water. Make crankcase inspection to look for water dripping from the ethers inside of the cylinder bore, top seal. Leak from the bottom of the outside part of the cylinder skirt, lower liner seal link. Cylinder blow by. Perform blow by test. Defective cylinder piston. Replace defective components. Pledge inverted crankcase breather screen. Clean screen. Check for proper insulation. Crankcase overpressure trip. Switch out of calibration. Calibrate switch. Defective switch. Replace switch. Other engine troubles. Hot engine. Serve cooling water system related problem. Check the cooling water system and list with the low water pressure trip. If no fault is found with the cooling water system, test the LOTS switch for the not to be indicated with the high lube oil temperature has been occurred. Failure fan drive. Check if the fan is running on the GE locomotive. The fan always runs while the engine is running. Dry radiator air passage. Check the radiators. Plug air inlet screens. Check the screens. Clean the screens, dirty lube, oil cooler either side, replacing cooler tube bundle. Engine overspeed tripped. Stuck control rack linkage, remove the governor link pin and check the linkage of binding. Defective overspeed governor is set too low. Replace the overspeed governor, reset and place on the engine overspeed should be 1150 RPMs. Injection fuel pump rack stuck open. Reset the racks to reduce linkage binding. Defective engine governor. Replace governor. Low fuel pressure. No fuel. Check the fuel in the tank. Add fuel. Dirty fuel strainer. Check strainer. Suction leak line. Locate leak and repair. Dirty fuel filter. Check filter. Defective fuel transfer pump rate. Motor. Replace motor. Deregulating valve set too low. Reset the valve to 40 psi. Release safety valve leaks. Replace the valve. Relieve safety valve to set too low. Reset the valve to 75 psi. Alright, fuel dilution, defective nozzle. Post pop test each cylinder with a check of the weak and the not firing cylinder. Repair and replace nozzle. Fuel dilution, defective fuel injection pump. Replace fuel pump. Cold engine. Replace thermostat. Clean orifices and pilot valve. 3. All circuit breakers, engine control panel closed or on. No indication lights and the alarm bell rings. 5. The battery switch is closed. The operator control switch set up for the proper operation. 7. The air brake set up for the proper operations. 8. All air pressure gauges are normal. 9. Power limit set up the notch switch in normal operation position. 10. Reverse handle in normal position. 11. Generator field switch in the off position. 12. Pop test. All cylinders listen carefully. All unusual noises coming from the engine room sides of the engine, fuel and oil, water leaks. Alright, your low oil level of low oil level should be result of the LOP. Failed bearings or bearings, LOP. Lube oil pump failed, LOP. Overspeed governor, low output pressure, LOP and LWP. Overspeed Lincoln failed, low pressure and low water pressure. Low oil diaphragm failed. Low oil pressure. Low water diaphragm failed. Low water pressure. Low engine speed. Low oil pressure. Low water pressure. Low stuck racks. Low oil water pressure. Low water pressure. Defective load pilot. Low oil pressure. Low water pressure. Engine bog due to sticky fueling. Low oil pressure. Low water pressure. Lube oil viscosity. Low oil pressure. Bonded rubber pump drive sheared, low oil pressure, low water pressure. Pipe plug missing cavity in top forward end of the cover. Low oil pressure, crankcase overpressure. Plug crankcase breather, crankcase overpressure. Crankcase breather screen inverted large mesh up. Crankcase overpressure, broken crankcase indicator, crankcase overpressure. Water pump failed, crankcase. High oil level, crankcase overpressure. Water pump failed, low water pressure. Wrench on lay shaft, engine overspeed. Failed governor drive, none. Faulty governor, low oil pressure, low water pressure. Faulty governor, engine overspeed. Faulty engine overspeed cover adjustment screw loads. Engine overspeed. Fuel injection pump. Fuel linkage. Engine overspeed. Fuel low water pressure. Low oil pressure. 26. Faulty overspeed engine governor. Crank overspeed. Failed turbocharger. Low oil pressure. Low water pressure. Plugged intercoolers. Low water pressure. Low oil pressure. Inlet port carbon. Low oil pressure. Low water pressure. Cracked piston. Crankcase overpressure. Next are all stuck rings, scored rings, crankcase overpressure, dry piston rings after extended shutdown, crankcase overpressure, cracked piston crankcase overpressure, wrong piston rings applied, crankcase overpressure, cylinder wall leaks into case causing oil level to be too high, crankcase overpressure, dynamic braking a long period for the ambient temperatures, low oil pressure, engine won't crank, none, faulty COP or crankcase overpressure. Are the GSDHR tripped? None. Intermediate fuel cutoff switch, engine stop pushing button, none. Emergency shutdown throttle, none. Engine stop push button has been pressed, none. Excessive excitation, low oil pressure, low water pressure. Control grounds, low oil pressure, low water pressure. Transit, low oil pressure, low water pressure. Fuel pump relay coil failed, none. Low fuel pump motor failed, low oil pressure, low water pressure. Locomotive system, black oil strainer, low oil pressure, control cover oil painter strainer, defective cover gasket, low oil pressure, fuel drain back valve C open, low oil pressure, plug lube oil cooler, oil slide, oil pressure, plug lube oil cooler, water slide, low oil pressure, low water pressure. Low water level, low water pressure, water tank filling tank, missing, loosening, defective low water pressure, water storage tank, defective baffle split on the block screen, cracks and tank, low water pressure, water leak, low water pressure, hot water, low oil pressure, relief of the oil valve, low oil pressure, plugged fuel filter, low oil pressure, low water pressure, plugged engine air filters, low oil pressure, low water pressure, lube oil level too high, crankcase overpressure, warning, wrong lube oil dipstick, low oil pressure, crankcase overpressure, block breather pipe and exhaust stack, crankcase overpressure, air blowdown, crankcase overpressure. If you're leaking oil line off between overspeed governor and link, overspeed contact, overspeed switch, fuel tank empty, fuel problem, low pressure, low and no pressure, low oil pressure, low water pressure, no fuel problem, excessive leakage, fuel section line, seal fuel transfer pump, low oil pressure, low water pressure, fuel, ice fuel tank, fuel strainer, wax fuel strainer, fuel problem, plugged lube oil filter, low oil pressure, wrong exhaust, low crankcase overpressure, crankcase overpressure, broken oil pipe, low oil pressure, hot oil, low oil pressure, low no radiator cooling, dirty radiator fan stop, low oil pressure, low water pressure. Alright, oil level at near the full mark, water temperature gauge 150, 175 degrees Fahrenheit, water site level approximately 170 degrees Fahrenheit, should never be higher at the idle mark. Warning pump with the leak, seal leak, check with the water dip in the platform. 6 water fill with the pressure cap in play for the air compressor for the oil leak for the radiators, fan is turned with the dynamic braking rids for the burn for the open ribbons for the burn, insulator for the barriers, preliminary check in the cold weather. The following check should be performed with the help of the prevent cold weather trouble, the possible road shutdown. The check for in addition to the normal railroad check, the procedure of the cold weather service. Ensure there are no brakes in the traction motor air duct that would permit the moisture of the engine. Ensure that no brakes at the seal of the control compartment door of the would permit the moisture of the enter. And assure the winter and summer door in the proper position. Assure the fuel heaters and install this operating properly. Assure the properly oiled for cold weather service using governor F5 weight W30 10W30 depending on the railroad cold weather service requirement. Ensure the fuel filters are clean. Ensure the fuel strainer is clean. Note the fuel oil patch gauge it must indicate 25 psi in notch 8 when checked on the self-loaded load and lower load box. If no recheck cleanliness, fuel filters and strainers assure horsepower is proper to each of the notch. There should be no engine bogging. The governor modulation. Check on the lube oil filters cleanliness. If dirty, replace filters. If lower horsepower is low, check the engine. RPM. Also, ensure the idle is correct. See the note below. The low oil speed will cause the road shutdown when returning the idle correct speeds at 450 RPMs. Attack drive at 668 RPMs. Assure batteries in good condition, fully charged. 10. Assure the voltage regulator is operating properly. 74 volt DC at idle. If permitted, the railroad rules add alcohol to fuel tank to prevent freezing, using only 1 gallon of alcohol per 1,000 gallons of fuel. If the engine cranks without starting, check with the overspeed link with the overspeed governor. Press for the may reach the 200 psi. If the link becomes fully compressed with the greater psi at 120, does not full compress with the replace for the overspeed of the tank. If the pressure is less than 95 psi, replace the overspeed governor regulating valve. Note, the oil pressure during the crank without the manual rack exists. It should be not less than 95 psi, less than 175 psi when the engine is idle speed. The oil pressure for the 200 psi higher is considered standard. The GEMS Volume 3 issue, GEMS Volume 3 Issue 4, dated December 10th, 1974. Note, if the equipment has been properly maintained above the 12th step, it has been performed satisfactorily with a single main start from the operator's cab possible. Engine run check. Also, after the preliminary check that has been completed, after everything has appeared normal on to this point, proceed the following: run the engine with the 8th throttle notch, no load. Read all the gauge of the normal setting. Return the throttle to idle. If everything appears to be normal, set locomotive brakes and set for the power. Set up for power. Open the throttle of the notch 1. Check the load meter. Read up the scale. No, it's normal notch 1 current approximately 30 amps. Return the 300 amps and return the throttle to idle. If reasonable, sure that there are no malfunctions with the engine speed, produce the electrical locomotive system checks. Alright, table 12.3, exhaust smoke analysis. Alright, black smoke puffs, one or more defective injectors. Recondition, check the defective injectors. Fuel pump, the rack is stuck. Free the rack and change the pump. Fuel pump rack is set too high. Look at the high rack and readjust. Fuel pump is out of timing. Adjust timing. Warm damaged turbocharger. Repair and replace turbocharger. Broken and leaking manifold pipes. Repair and place manifold. Engine speed is bogging down. Check the engine over operation circuit for fault. Turbo is surging. Inlet ports were partially blocked and turbo is misled. Check the nozzle ring of the diffuser. Check the inlet ports for dirt. Check inlet ports if dirty. Turbocharger rotor is stuck. Replace turbocharger. White smoke puff. Fuel pump is out of time. Adjust timing. Check cylinder valves are burned unstuck. Replace cylinder. Engine is too cold. Wait until the engine warms up. Cylinder with low compression. Replace cylinder. Fuel system is airbound. Bleed the fuel system. Blue smoke is also out of the checks. Failed turbocharger bearing seals. Replace the turbocharger. Worn broken piston rings. Replace rings. Cracked piston crown. Replace piston rings. Scored liner. Replace cylinder and rings. Prolonged operation of the engine at idle. Loaded engine condition should be clear up. Steady smoke exhaust stream. Worn leaking injectors. Change injectors. Late pump timing of all the cylinders. Timing the engine pumps. Water out of stack. Cylinder seal leaks. Cracked turbo lead. Locate and correct. Blown exhaust system. Broken exhaust manifold. Repairs place manifold section. Valve tappet clearance is insufficient. Readjust. Cylinder valve is stuck open. Replace cylinder. Cylinder valve the seat is guttered. Replace cylinder. Floating unit or self-loaded check. Is assumed that control devices are properly set with the inspection of the item at the water level, the oil level, the battery voltage have been performed. Note for the details instruction further, section 11 for the composite manual. Start the engine running the idle and check the lube oil pressure at 25 to 35 pressure at psi with the water at normal temperature. Full pressure approximately 40 psi. The smokestack table 12.3 with smoke from the sound for the engine with a heavy pound with the rap knock with the clatter audible indicator for the trouble. Pop test cylinders. Observe the exhaust for the smoke. Table 12.30. Voltage regulator. Volt 73.5 to 74.5 volts. DC. Water fuel. The oil leaks. Governor oil. Proper level. The cleanliness. Rack readings of the fuel injector pumps. Slowly move the throttle handle to notch 8 position. Check. Lube oil pressure from the 95 to 150 psi. Higher if the oil is cold. Fuel pressure 25 to 36 psi. Tube oil turbo air pressure 20 to 32 pressure. Will verify the atmospheric pressure and temperature. Water temperature 170 to 880 degrees Fahrenheit. Engine air filter surface indicator not trip. Brake cylinder pressure 45 psi. Minimum cylinder air pressure. Exhaust table 12.3. Airflow out the radiators. No debris in the dirt in the air with the passage air manifold leaks. Include turbo elbow exhaust manifold leaks. Water tank sight glass for the trace of the oil or carbon. Governor loading pot position maximum field power voltage current with a constant CHEC panel test point. Check loading excitation. Move the throttle to idle, then move the notch 8, and then observe the exhaust smoke of the table 12.3. Time required for the full horsepower, engine speed stability, hunting the throttle handle with the idle, then perform the engine shutdown procedures. Horsepower trouble. No horsepower engine running. Open throttle set of the engine. Responding to the contactors. Pick up with the load meter. Includes the upscale of the engine. Does not respond with the down speed. Check the engine's control with the ensure the all breaker switches are improperly operating with a position. I'll check the output with the voltage regulator panel. The 34 volt DC battery charging voltage. Shut the engine down. Inspect the throttle with control wiring for the continuity. Check the governor solenoid if they're operating properly. Check the governor plug is properly seated. If the engine responds with the throttle but no load, but should engine down and check. Exciter brushes, alternator and slip ring brushes, generator brushes, control air pressure contactor and relay sequences. Assure generator field control excitation breakers are closed. The crank of the engine under load and under no load condition. Check with the output of the alternator rectifier and the GA and GN wire for the engine with the idle with the notch 1 through notch 8 position. Refer to the rectifier exciter alternator section of the applicable locomotive schematic location of the test points to measure the GA, GN voltage of the 150 volt DC, 1500 volt DC measure needed. Tested volt reading of the notch 8 no load will vary from 1200 volt DC to 1500 volt depending on the model of the locomotive. Refer to the load testing section 11 for voltage for each of the model of the locomotive. Excitation panel cards. A quick check of the involved with the setting of the locomotive up to the load open throttle with the notch 1 with the voltage. Check with the signal throttle standing of the governor etc. through the excitation system until the signal is lost. Then go back one step to find the trouble. Low horsepower engine running. Check power limited switch for the normal position. Motor cutoff switches to the all in position. Engine is not smoking. That sounds normal. Reduce excitation indicator lighting on the EC panel and the annunciator panel is not lit. Shut down the engine, check the rack linkage, not binding visual inspection of the engine for evident defects, manifold leak, disconnected fuel pump control links, etc. Check paper, air filter, red tags, flags for the dirty air filter, stop the engine, advance throttle to about 1/2 the speed, no load, or check. That overspeed link is fully compressed due to discharge pipe and the fitting of the intake with the manifold leaks. You will be able to feet and then feel and perhaps see or hear them. Remove the plug from the bottom of the turbo compressor casing and the feeling of the air from pulsing out of the hole. No oil, water present. If okay, replace the plug. No further investigation of turbo will be necessary. With the engine running top speed, no load, check fuel pressure. Assuming the gauge is not defective, if there's more 3-pound deficiency between the idle and the top speed readings, the engine is probably not receiving sufficient full fuel under load conditions. Determine why the dirty fuel filter, strainer, load regulator, etc. If the problem develops between 20 and 30 miles an hour, check the transition setting of the test set. If nothing found up to this point, the unit should be connected to the load box, self-loaded. Further check refer to the load setting section 11. The one thing to remember is that under load conditions, usually a load pot is met below maximum field, but the problem is usually mechanical. The maximum field of the problem is usually electric. If the horsepower is high, there may be both mechanical and electrical problems. Alright, turbocharger trouble. Generally mounted in the locomotive, the turbocharger figure 12.1 of the difficult piece for the equipment to check with the quickly qualified with the continuous serve of the turbocharger is frequently judged to be faulty on the basis of operation. Crew reports on basis of the systems not noted while the locomotive is being operated during the inspection process. If the systems noted but identified with the defective turbocharger frequently happen the same. The system will apply with all other faults of the locomotive. So many turbochargers are replaced unnecessarily. Refer to the table of 12.4. For example, the system showing multiple faults. Inspection of locomotives. Inspection on locomotive. The preferred method of qualifying a turbocharger for the continuous service is to observe the and its effects while load testing of the locomotive. Load testing, refer to load testing section 11, should only be performed after the establishing following items are functional and correct. 1. The fuel pump racks correctly set and equal to 2. The fuel pumps properly timed. 3. The fuel injection pump nozzles almost function. 4. Air intake exhaust manifolds free of leaks. 5. The valve tab at the clearance is correctly set. 6. The fuel filter engine air filters cannot be plugged. 7. Fuel linkage free moving. 8. The excitation circuit must be in good order. The capable of being adjusted. When entering full load with the notch 8, observe the turbocharger air pressure color, exhaust governing load pot action. Check for the turbocharger oil with the water leakage, mechanical distress. Table 4, 12.4. Identify the faulty turbocharger other locomotive component. When it is not possible to load test for the locomotive, perform the following turbocharger check with the locomotive shutdown. Work down through the stack with a flashlight and mirror position to the observe of the turbine displayed. Figure 12.2. With the observe of the blades by using a hook tool made from 1/8 inch diameter stainless steel to lift the rotor, rotate the rotor through one complete revolution. Examine all the blades for the possible damage caused. Form material to check with the rotor for free rotation. Performing the operation will often break up the carbon buildup with cover to reduce the rotor speed and allow it to continue the use of the turbocharger. Remove the clamps flexible air dust from the compressed end of the turbocharger. Figure 12.3. Manually turn the rotor. Note that the rotor is free, but the rotate set of the dial indicator move the rotor as required to check the axle radial clearance. Alright, the crew reports system black smoke out of the stack, steady state. The actual turbocharger fault, rotor not returning, rotor turning at reduced speed. The possible cause of the turbocharger fault, rotor damage foreign object with excessive carbon buildup between the turbo seal and disc, failed bearings, failed rotor, turbine disc, and compressed wheels and turbine disc rubbing. Other possible locomotive faults: injection pumps not properly timed, faulty fuel injection pumps and or nozzles, excessive carbon buildup in the air intake ports, dirty intercoolers, plugged engine air filters, leakage in air intake manifold, faulty excitation circuits adjustment or components, not loading or low power. Rotor not turning, rotor turning at speed, reduced speed on the actual turbocharger fault. Rotor damage of the foreign object, excessive carbon buildup between the turbine seal and disc, the failed bearings, failure of the rotor, turbine disc, and compressor wheel, or turbine disc rubbing. Other possible locomotive faults: dirty plug fuel filter, fuel pump rack set incorrectly, valve tappet clearance set incorrectly, leak in manifold line of the governor. Also see faults that listed above the blackout smoke out stack. Blue smoke and oil out of the stack, failed bearings and or seals, pipe plug missing upper cavity over the front end of the cover, the wrong size orifice and loop, oil pressure supply pipe, rotor unbalanced, worn broken piston rings, cracked piston, ground scored liner. Blue smoke oils out of stack, seal air passage plugged with carbon or labyrinth with a turbine end seal plugged with carbon, prolonged operation of the engine in idle operate lower speed notches. Alright, load turbocharger air pressure at notch 8 full load. Rotor turning at reduced speed, excessive carbon buildup between the seal and disc, defective bearings, compressor wheel, with the turbine disc rubbing, leakage air at the discharge elbows, air intake manifolds, leak in the exhaust manifold, faulty gauge. Also see faults listed above low on power. Low turbocharger air pressure at less than notch 8 full load. Possible no fault turbocharger air pressure and not indicated until the notch 6 above and under load. There's no indication when in dynamic braking. Refer to the data section, torque value section, limits, warning. When you use the compressed air for the cleaning of the purpose of environmental potential hazard, personal and intermediate air is created to prevent physical injury, flying debris. Observe all railroad OSHA safety regulations. 3. Check the plug seal, the air passes, disconnect the seal air pipe to apply the shop air into the seal air passes, the tube turbine casing in place. Scissors are clear and sound of the escaping air will be heard in the stack outlet with the operation can often clear the partially blocked passage. Check visually for the evidence of mechanical damage, excessive heat, and water leaks. Alright, figure 12.2 shows the inspection turbine bucket blades. Apply the hook tool to the face of the turbine disc to rotate the wheel, rotor. Rotation, adjustable mirror, exhaust gas outlet passage flashlight. Alright, your data, your weight turbocharger, 1,470 pounds, rotor end plate, new 3,000 to 21,000 an inch, max worn 25,000 of an inch, rotor diameter clearance and bearings 3,000 an inch, or 55,000 of an inch, 10,000 of an inch, max worn 65,000 of an inch, speed pick probe at the cap clearance 28,000 inch, 90,000 of an inch. Oil supply pressure measured by the air turbine case inlet with the idle temperature at 160 to 190 degrees Fahrenheit. The engine idle 10 to 20 psi. The engine at notch 8, 15 to 40 psi. Figure 1230 turbo installation details compressed. Clamps 2 of 8 flexible air aspirator hose. Flexible duct clamp 1 of 2. Crankcase breather exhaust stack air duct turbocharger cooling water flow control valve. Alright, your torque values. Bolts turbocharger mounting 150 to 165 pounds. Bolt stack and clamping 55 to 60 pounds a foot. Torque bolts exhaust manifold turbocharger 70 to 75 pounds of torque. Nose stud and locking ear clamp. The air discharge elbows 55 to 60 pounds of torque. Bolts flange and intercooler 35 to 40 pounds of torque. Alright, modulating controller governor trouble. The modulating control governor electro-hydraulic device used to regulate speed, horsepower, output of the diesel engine, include the number of auxiliary devices such as water pressure switch, oil pressure switch, protect to provide the power plant with the characteristics desired by the railway locomotive service. The characteristic device operational events are shown in figure 12.4. The figure consists of the four tracking charts that show normal and abnormal operating events, but the action should be taken to correct the abnormal events. The four tracking charts are normal condition, power, engine starting, normal condition, dynamic braking, hot engine controls. The CHEC excitation trouble. The major components of the CHEC excitation system is the FL138 excitation panel. Therefore, the emphasis has been placed on the troubleshooting of this panel. Table 12.5 shows a list of 10 cards in the panel. Their function, the first 9 cards are the same, and then all panels with a different model of the General Electric locomotive. The length, the 10th and reference card are different for each model of the locomotive. For each model of the FL138 excitation panel, table 12.7 or 6. No, the maintainer should not assume that, for example, that all C37 locomotives will have the same model of the FL138 panel, thus the same type of the reference card. The model of the FL138 panel installed on the C37 locomotive depends on the type of the turbocharger installed. Caution: power should be removed when pulling the replacing electronic cards to prevent electrical damage to the cards and their contacts in the panel. Alright, we got the engine modulation governor tracks. Alright, normal condition, dynamic braking, engine start blank, engine hot, engine controls. Look for this in the sway that I'll do. Table 12, 5 card data inspection. Position left to right. 1, card symbol, TC, card test, card title test. Card number FT731. Check reserve left of the contract strip of the panel. Replacement by check hit plug during the system test of the check. No components are blown on it. However, the interlocking wire must be in place on the unless check it is plugged in. 2. The FT field current. The FT733 provides variable current to the shunt field of the exciter GY27. 3. The MD modulator FT734 controls variation of shield field current. 4. Position left to the right. 4. The carb symbol MP multiplier. The FT735 generates power signal multiplied the voltage current signal supplied to it. F. Position left to right. Position 5. The card symbol TS turbo speed FT736 generates single proportional to turbo rotor speed. The position left to right 6. The card symbol CP, the comparator. FT737 determines whether various signals control the locomotive power output, the amount of dynamic braking effort developed. Position left to right 7. The card symbol FL, the filter FT738, smooth signal for the ACCR, BCCR, VCR. Reactors furnished with the 2 signal with a commutator card. 8. The OS oscillator FD739 generates 400 Hz of signal to excite 3 reactors ACCR, VCR, BCCR, slash power to the RG card. 9. From left to right. Card symbol RG regulator FD740 supplies regulated positive and negative 15 volt power to certain cover the 4 relays. Repeat the throttle command on the multiple unit train wires. 10. The RF for the reference, the card for number, the FTC table 12.6. Preset the power current voltage line limits each of the throttle notch furnished with the power match signal when specified the modification turbo speed signal. The FT733 card, FT, sometimes referred to the field transistor card, field switch card, or field control card. Our table 12.7 presents the procedure qualifying locomotive is the procedure for the visual check, which can be performed without testing equipment. It's suggested the maintainer use the check of the diagnostic and analyze for the convenient dimension, checking with the overall electrical excitation system without checking. With check it, the card plugs the insert of the F138 panel to place on the FT732 test card. The maintainer can observe the operation of the constant horsepower and excitation system during normal locomotive road operation during load testing and detailed test instruction including the check kit. However, if the check kit is not available, to refer to table 12.8 The table list for the troubleshooting trouble system of the possible service cause for the substitution assumed grade with the suspected malfunction card fastest method troubleshooting panel. If the problem still cannot be resolved after checking the possible cause for the table 12.8, perform the load box check, and if the locomotive is so equipped that so the self-load check. For detailed instruction, refer to load testing section 11. Alright, the table 12, section 6, reference card locomotive, the B118 reference card B187 FD894, B237 FD861, B237 FD897, C237 FD868, B287 FD895, C287 FD896, B37 58862, C37 FD741, C37 FD1146, C37 FD1202, B33-7 FD864, C33-7 FD863, B36 FD866, C36-7 FD655. Alright, the table 12.9 is presented additional aid to the maintain the table list for the test point for the cars in the FL138 check constant horsepower and excitation system panel. These test points are color coded as follows. Black is common, blue is DC signal voltage measuring device, orange is the plus and positive voltage DC power, white is the negative 15 volt DC power, brown is throttle notch, yellow is the AC usually oscilloscope used, green is the DC rectifier voltage. Alright. I mean, look how many pages we got left to go. We're going to cut the tape right there at the at page, we're on page 16.